Hello and welcome to Patch Math, where today we are going to patch your math knowledge on simplifying radicals. You'll see here that specifically we are dealing with radicals that has a fraction in it. One of the things I like to show my students is the relation to exponent rule. And here they are. So if you'll see, we have what's called the fractional exponent rule. AKA, if we have a square root or a radical of some kind, cubed root, fourth root, you name it, and then something, it can have an exponent. Even if there's not an exponent on the inside of the radical, there's always an invisible exponent of 1 that we will need to consider. But this definition right here tells us that radicals are just exponents in disguise, fractional exponents in disguise to be exact. So what that means is we can apply power of a quotient rule, because this radical of this fraction is just a power that is on this quotient. Applying that rule, I'm going to go ahead and break up this into the square root of 3 over the square root of 18. Now our goal here is to simplify completely. We look at the numerator and we have, can I pull out any perfect squares there? And the answer is no, because 3 is prime, so we cannot take a perfect square root of that. The numerator is currently in simplest form. However, if we come down here and we look at this denominator, it's not clear as to whether it's in simplest form because it is a composite number. It is not prime. So we're going to use a method called prime factorization. And an organization method of prime factorization is a factor tree, a prime factor tree at that. So it's even. I immediately like to pick 2. 2 times 9 is 18. If you're using the perfect square method, you might stop here. But if you're one of my students, I prefer just to break it down into all of its primes. It really helps us when we get to variables. 9 can be broken down into 3 times 3. Both of those 3's are prime. And we are done with the prime factorization, that is. I'm going to go ahead and rewrite this. Notice that was just kind of scratch work here. This whole thing comes down here. And we are now equal to that numerator stays unchanged at this time. And our denominator becomes the product of those primes. If we multiply all the prime factors of a number together, we will get the original number back out. So if you want to check yourself to make sure you factored or prime factored 18 correctly, well, 2 times 3 is 6, and 6 times 3 is 18. So that is the square root of 18. Now, why did we do this? You're about to see why. Here, that radical 3 in the numerator, we're going to leave it unchanged. But that denominator, we can organize things. We know that squares undo square roots. And that I got tongue tied there. And that square roots undo squares. So we also have a power of product rule that says if we have a product being raised to a power, that product being on the inside of our parentheses, that power comes into each factor. Now, that radical is just an exponent in the sky, so I'm going to reorganize this into 3 times 3, which is 3 squared, times 2. And this right here is that little bit of commutative property there. There's this 2 here. For my students, I love to color code. And we just keep on keeping on. That power of a product rule that I just highlighted says that we can take the square root of 3 squared separately from the square root of 2. That's important. Square roots undo squares. So this undoes that. You'll see that our numerator becomes the square root of 3, or not becomes, it stays the square root of 3, and 3 square roots of 2 in the denominator. Now, you might stop here, but do have to rationalize, and that denominator is not rationalized. There's just a real quick way to informally remember what rationalizing means. So right now, this numerator is going to remain untouched. And we're going to use our denominator to inform what we're going to multiply this by. Now here's something that's important. Whatever we put in this parentheses must reduce to the number 1. We can multiply anything in any number by 1, and we get that original number back out. That's that identity property of multiplication there. So in this scenario, if I want a square root to get out of my denominator, we know that square roots are canceled out by squares. I'm like, well, I can multiply that denominator by the square root of 2, and then suddenly I have the square root of 2 squared, and poof, that square root is canceled out. All right, so we have to have a value of 1. What we multiply the denominator by, we must multiply the numerator by, and you can type it into your calculator if you're not sure. But the square root of 2 over the square root of 2 does equal 1. So this thing is just going to change the way it looks. We are going to use the power of excuse me. Yes, we are going to use the power of product rule, but in reverse. We know that if we have a product raised to a power, we can separate it like we did. But notice that we have these two factors. They have the same power. So we can go back a step, and that square roots of 3 times 2 can come under that same power. Moving on, looking at that denominator, that's the part that we care about. That 3 stays there, and now suddenly, using that same thing, we got the square root of 2 times the square root of 2. That is the square root of 2 times 2. And we keep on keeping on. Yes, I know I'm showing every little detail, and sometimes that can be exhausting. But I want you to know exactly why and how we do this. Now, that numerator, I was just getting ready to rewrite it there because I can't seem to think them right at the same time. 3 times 2 is 6. That denominator, that 3 on the outside, is going to remain where it is. That is the square root of 2 squared. Square roots undo squares. Those square roots undo squares as DJ joins our problem-solving team. Our numerator is the square root of 6. And we know, before we combine that, I did skip over that part, that because 3 and 2 are both prime factors, there are no perfect squares in there that we can pull out. Now our denominator, this right here, is what canceled out. Square root of 2 squared, and square roots cancel out squares, so we are left with 3 times 2. Simplifying that denominator, 3 times 2 is 6. So the numerator stays, the square root of 6, the denominator becomes 6. At this point, you may be trying to cancel out those 6's. Please do not. They are not the same thing. One is inside of a radical, one is in the denominator. We cannot cancel them out. Now, if we want to change form, that's an option by using exponent rules. We know this is raised to a power of 1. That's one of those invisible ones in mathematics. And we know the square root using that fractional exponent rule is 6 to the 1/2 power. And this is 6 to the 1. And we can choose to use, looking at our exponent rules, where is it? Quotient rule that says we have the same base. We can subtract their powers if those bases are being divided. And so that would be 1/2 minus 1 here, which would be 6 to the negative 1/2, which happens to be 1 over the square root of 6, and then we go in a big old circle and have to rationalize again. So that would not be helpful. But if we needed to change form for any reason, it's there. This right here is our complete and final answer. And zooming out, there is your refresher on how to simplify radicals and rationalize the denominator. Me and DJ would like to thank you so much for your time.